Hello students, welcome to my class. In today's class, we will continue with the chapter Trigonometric Functions of class 11. So in the previous video, we have learned how to find the principal solution and general solution of a trigonometric equation. Now we are going to do exercise 3.4. So the first question, find the principal and the general solution of the following equation. So the first question is tan x is equal to root 3. So first we have to find principal solution. So for finding principal solution, you check here tan is positive. So in which quadrant tan trigonometric ratio is positive? First and third quadrant. You know that first is all positive and the third quadrant tan and cot are positive. So these are the two quadrant where tan x is positive. Okay, so in the first quadrant the angle is x, but in the third quadrant we have to find pi plus x. The angle is pi plus x. Okay, so here tan x is equal to root 3. So for which angle? Tan value is root 3. Root 3 for 60 degree. So 60 degree means pi by 3. Okay, so tan pi by 3 is equal to root 3. So we got one solution. So x is equal to pi by 3. This is the first one principal solution. So this pi by 3 lies in the first quadrant. Now we have to find the angle in the third quadrant. We have to find the angle in the third quadrant. So tan pi plus pi by 3. So here x is pi by 3. So tan pi plus pi by 3 is equal to root 3. So this is also root 3 only. So we can simplify this. Tan of 3 pi plus pi, that is 4 pi by 3 is equal to root 3. So we can say x is equal to 4 pi by 3 is a solution. So pi by 3 is a solution and here 4 pi by 3 is a solution. This is also a solution. Therefore the principal solutions are, so first we have to find the principal solution. So the principal solutions are pi by 3 and 4 pi by 3. So what is principal solution? We have discussed in the previous video. The angle, the value x between 0 and 2 pi is called the principal solution. So these are the principal solution. Now we will find out the general solution. If you want to find general solution, we need a one principal solution. So now from these two equations we can write tan x is equal to tan pi by 3. So we are going to use the theorem now for finding the general solution. What is the theorem? If tan x is equal to tan y, then x is equal to n pi plus y, where n belongs to z. This is the theorem. So using that theorem we can write x is equal to n pi plus, here in the place of y what we have? Pi by 3. So x is equal to n pi plus pi by 3, where n belongs to z. So this is the general solution of the equation. Okay, now we will see the next question. Now the second question is sec x is equal to 2. So here if you see, we have the trigonometric ratio sec. So we will change it into cos. So we can write cos x is the reciprocal of sec x. So cos x is equal to 1 by 2. So the given trigonometric equation we can rewrite as cos x is equal to 1 by 2. Now we are going to find the principal solution and the general solution. Here if you see, cos is positive. So in which quadrant cos value is positive? In first and the fourth quadrant cos is positive. Now we will find out the angle in the first quadrant. For which angle cos value is 1 by 2. Cos 60 degree is equal to 1 by 2. So 60 degree we can write as pi by 3. So cos pi by 3 is equal to 1 by 2. So x is equal to pi by 3 is a solution. This is one of the principal solution. Now you have to find out the angle in the fourth quadrant. In fourth quadrant we can use this formula for finding the angle, that is 2 pi minus x. So cos 2 pi minus x is pi by 3. This is equal to, this value is also 1 by 2 only. Now we will simplify, that is cos 6 pi minus pi, that is 5 pi by 3 is equal to 1 by 2. So x is equal to 5 pi by 3 is a solution. So this is the second principal solution. Therefore, principal solutions are pi by 3 and 5 pi by 3. Now we are going to find out the general solution. So for finding the general solution, any one of the principal solution we will take. So we will take this value. Okay, so we will consider these two equations. So from the given equation, we can write cos x is equal to cos pi by 3. Now we will use the theorem. What is the theorem? If cos x is equal to cos y, then x is equal to 2n pi plus or minus y, where n belongs to z. So this is the theorem. Using this theorem, we will find out. So x is equal to 2n pi plus or minus, what is the value of y here? Pi by 3. So 2n pi plus or minus pi by 3, where n belongs to z. So this is the general solution of the given equation. Now the third question, cot x is equal to minus root 3. So here in this question, we have cot value, trigonometric ratio. So we will change this in terms of tan. So we can write tan x is equal to, tan is the reciprocal of cot. So tan x is equal to minus 1 by root 3. Now you see here tan is negative. So in which quadrant tan value is negative? Tan x is negative in which quadrant? Second quadrant. First quadrant tan is positive, and in the third quadrant also tan is positive. So second and the fourth quadrant, negative in second and fourth quadrant. Okay, so these two quadrant only tan is negative. Okay, so now we will find out the value of x for which angle tan value is 1 by root 3. So for which angle 1 by root 3? That is 30 degree. So 30 degree means tan pi by 6. So x is equal to pi by 6. So we got x is equal to pi by 6. Now how will you find the angle in the second quadrant? Pi minus x, and in fourth quadrant 2 pi minus x. So we will calculate. So tan pi minus pi by 6 is equal to minus 1 by root 3. So here we will simplify. So tan 6 pi minus pi, that is 5 pi by 6 is equal to minus 1 by root 3. So we got one principal solution, that is 5 pi by 6. Now we will find out. So x is equal to, we got x is equal to 5 pi by 6 is a solution. So this is a solution. Now we will find out the angle in the fourth quadrant, that is tan 2 pi minus x, that is 2 pi minus pi by 6 is equal to minus 1 by root 3. Here when you simplify, 12 pi minus pi, that is tan 11 pi by 6 is equal to minus 1 by root 3. Okay, so x is equal to 11 pi by 6 is a solution. So we got the principal solution. The two principal solutions are 5 pi by 6 and 11 pi by 6. Now we have to find out the general solution. So for finding general solution, we will take this value. First value we will take. Okay, we will consider these two equations. So I can write tan x is equal to tan 5 pi by 6. So what is the theorem? If you have tan x is equal to tan y, then x is equal to n pi plus y, where n belongs to z. So this is the theorem. So using this theorem, we can write x is equal to n pi plus, here in the place of y what we have? 5 pi by 6. So 5 pi by 6 comma, where n belongs to z. So this is the general solution of the equation. Now we will consider the next question. We will see the next question. Now question number 4, cosec x is equal to minus 2. So we will change cosec x in terms of sine. So sin x is equal to minus 1 by 2. So here if you see sin x is negative, in which quadrant sin x is negative? First two quadrants sin x is positive. So in the third and the fourth quadrant only sin x is negative. So in third quadrant we will use 5 plus x formula for finding the angle, and in the fourth quadrant 2 pi minus x. Okay. So first we will find out for which angle sin value is 1 by 2, that is 30 degree, that is pi by 6. So x is equal to pi by 6. So we got x value is equal to pi by 6. Now we can write sin x is negative in fourth and fifth quadrant. Okay, sin x is negative in fourth and fifth quadrant. So now we are going to find out the angle in fourth and fifth quadrant. So in fourth quadrant the formula is pi plus x. X is pi by 6. So pi plus pi by 6 is equal to minus 1 by 2. We will simplify this, that is sin 7 pi by 6 is equal to minus 1 by 2. So we will get x is equal to 7 pi by 6 is a solution. This is a solution. Okay. Now we will find out the angle in the fourth quadrant. That is fourth quadrant formula is 2 pi minus x, that is 2 pi minus pi by 6 is equal to minus 1 by 2. Now we will simplify. 12 minus pi is 11 pi. So 11 pi by 6 is equal to minus 1 by 2. So x is equal to 11 pi by 6 is a solution. Therefore the principal solutions are, so what are the principal solutions? So the principal solutions are 7 pi by 6 and 11 pi by 6. Okay. Now we will find out the general solution of this equation. So we will use any one of the principal solution. We are going to consider these two equation. Okay. So from these two equation we can write sin x is equal to sin 7 pi by 6. So we will use the theorem sin x is equal to sin y. If sin x is equal to sin y, then x is equal to n pi plus minus 1 the whole power n into y, where n belongs to z. So this is the theorem. Okay. So using this theorem we can write x is equal to n pi plus minus 1 the whole power n into, what is the value of y? 7 pi by 6, where n belongs to z. So this is the general solution of the equation. We will see question number 5. Cos 4x is equal to cos 2x. So how we are going to do this? We will see now. So cos 4x into, we will take this cos 2x to the left side. So cos 4x minus cos 2x is equal to 0. Now we got the identity cos x. We are going to use the identity cos x minus cos y. So what is the formula? Cos x minus cos y minus 2 sin x plus y by 2 into sin x minus y by 2. So this is the formula cos x minus cos y. So we are going to use this formula here, that is minus 2 sin x plus y by 2, that is 4x plus 2x by 2 into sin x minus y by 2, 4x minus 2x by 2 is equal to 0. Now we will simplify here, that is minus 2 into sin 6x by 2, that is 3x into sin 4x minus 2x is 2x by 2, that is sin x equal to 0. Now we will take this minus 2 to that side. We can divide by minus 2. So sin 3x into sin x is equal to 0. So what we can write? Sin 3x is equal to 0 or sin x is equal to 0. Now you know that what is the condition when you will get sin value is 0 for the integral multiple of pi. So we can write from this 3x is equal to n pi, or x is equal to n pi by 3, where n belongs to z. Okay. Now we will go to the second equation, sin x equal to 0. Here also x is equal to integral multiple of pi. So x is equal to n pi. So we can write the solution as x is equal to n pi, where n belongs to z. Therefore the solution is x is equal to n pi by 3 or n pi, where n belongs to z. So this is the solution solution of the fifth question. Okay, so we have completed 5 questions in exercise 3.4. So the remaining question we will discuss in the next video. If you like my channel, you can share and subscribe. Your subscription my motivation. Thank you, students.